Let's start with the part of network security, and here we will discuss what are the key practices of securing networks and what are the key devices that you expected to see in network security. The first device, of course, will be the firewall, and the firewall in general, we should look at it as an operating system. Generally, any device is just a hardware, but what gives the hardware the capability to think and interact is to have an operating system. So firewall is simply a hardware that have a unique or a special operating system that can allow firewall to manage or apply authorization based on source IP and destination IP and enforce the network policy. Firewall can come in many forms. It can be network based and can be host based. So we all on our Windows or Mac or Ubuntu or Linux machines have a kind of host based firewall. So firewall could be software or hardware. Firewall generally are used to define the borders between networks. So assuming we have our network and this is our trusted area, and here we have the internet. So we usually place the firewall between the trusted and trusted area. That's why we say that firewall is defining the borders between the network, and it specify or indicate what is the trusted and the untrusted networks. We have many types of firewalls, but generally speaking, in real life, we don't use this distinction. But according to the content of the exam, we need to identify that there is many types of firewall, and we need to discuss which one or what is the benefit of each of these. So in the first type of firewall is what is called packet filtering firewall, and it works in layer 3 as per the OSI. The second one is the stateful inspection firewall, and it works in layer number 4. And third one is application level firewall, and it works in layer 7. What we need to understand here is in packet filtering firewall, assuming that we have a source and we have a destination, and we have in between a packet filter firewall. Whenever we need this source to be able to communicate with this destination, we need to create access control rule here. And this access control should approve that this source can reach this destination. But if I didn't configure a reverse rule to allow this destination to respond to this source, the access will be disabled. So the packet filter firewall is called a stateless firewall because it doesn't monitor who tried to communicate from the inside the network in order to auto allow the reply back. So in packet filter firewall, I need to care about allowing the outgoing traffic, which in this case the traffic outgoing from user to outside, and also make sure that I am allowing the inbound traffic as well. Is that clear? And this by so far not used in production environment anymore, but it was the most basic or the most simplest kind of firewall that was used in 80 and 90, by the way. So it is very old technology and it is not used. The second type of firewall is what is called stateful inspection firewall. And in a stateful inspection firewall, we have the user and we have destination. And the firewall has the capability to allow the request. We configure that we need to allow this source to reach this destination. But at the same time, while the firewall is allowing this access, it records the access in what is called a state table. So in case inbound reply came because there was an inbound traffic sourced from my network was requesting this asset, then the stateful packet inspection firewall will grant this access or will allow this response. Just to make you understand this better, in a stateful inspection firewall, we can allow someone from inside to communicate with the outside world. Is that clear? So stateful inspection, as long as we have a policy that permits this one to communicate with anyone else, will allow the outgoing traffic, which is going outside the network. This one will respond with data. So stateful inspection, when it sees that there is a reply that is received from the internet as a result from a previous request, it will allow this reply. But if the stateful firewall found that this server or this destination is trying to communicate with anyone inside the network without being requested from the beginning, it will deny this request. Does that make sense to you or not? Are you sure? Not sorry? Okay, good. The third level or the third type of firewall, which is now used in production or commonly used, is the application level firewall. And the difference between application level firewall and the stateful inspection firewall is that a stateful inspection firewall can only understand up to layer 4, which means I can allow for stateful inspection to communicate with HTTPS protocol because I am allowing port 443. But application level firewall could understand beyond this. Application level firewall could understand what is application that user is trying to open, what is the URL, and do a kind of restriction about which URL, for example, is allowed, which application is permitted, which cloud service can user reach. And this is a practical example for modern firewalls, which can be used in order to allow or deny traffic to a certain website or to a certain application. So this is the application level firewall. And the reason why it can read these applications because it can understand up to layer 7. If you remember the OSI model, when we said in OSI, we see the traffic as the human can see the traffic. So application level firewall can read applications, so it's able to detect malwares. We can find an antivirus that is installed on the machine, and we can also find a network-based antivirus, which can be on the firewall that monitors the traffic ongoing and outgoing and do a kind of packet decryption. By the way, user can communicate with the internet using SSL, but application firewall or application layer firewall can be able to decrypt this traffic if it has the private key which used in decrypting this traffic. And it can inspect this traffic first and ensure that it does not include malware or does not leak information outside the organization. We are familiar with the term DLP, right? Data leakage prevention. Data leakage prevention can be also host-based, which consists of or means that there is an agent installed on computers of the organization, and it can be also network-based, which means it can be also part of firewall. But this firewall should be application level firewall, because as long as it cannot read the application, it will not be able to detect viruses, do a kind of DLP functionality, and so on. DMZ is a kind or is area in the network that we place our servers that it will be published to the internet. And the reason why we implemented DMZ is to reduce the exposure. And I believe we answered simple or similar question. And the DMZ usually is placed between two firewalls. Why we need two firewalls? Just to ensure that we are allowing the internet to access our internal network, but it will not be able to pass the second network. So on the first firewall, which is before the DMZ, we allowing any to access our DMZ servers. But on the second firewall, we only allowing DMZ servers to access our internal network. That's why we are using two firewalls here. And the DMZ is called also a screened subnet. Like you are doing a kind of screening for traffic before entering your network. So you may hear the term in the exam, screened subnet, which is also referred to what? It also refers to the DMZ. Okay? Bastian Host or Bastian Host is a kind of system that is implemented in the DMZ. So any system or any server that is placed in your DMZ should be strongly configured and should be strongly hardened. And additional authentication measure is recommended with servers in the DMZ. What do we mean here is you have servers in your DMZ and you have administrator accessing these servers. You need to apply multi-factor authentication, especially when you are trying to access DMZ servers. Why? Because servers at the DMZ are subject to attacks. And by chance, maybe any one of these servers could be attacked and hacker could access this server remotely. The hacker after then will be able to read the database of users and hashes included on this server and could manage to crack one of these hashes. And then he will try to use the credentials to conduct the attack to other servers in the DMZ subnet. Isn't this a possible solution? So in this case, we will need to apply multi-factor authentication, especially in the DMZ. Clear? I know this is a lot of information, but I believe when you will reread the presentation, you will recall it at some extent. DMZ also includes the Honeypot. We usually place Honeypot in the DMZ because DMZ will be the most area of the network that will be subject to external attacks. So Honeypot will work as a detection or detective control to detect that if we have an intrusion happening in the DMZ area. And the DMZ usually used to seduce the hackers or seduce the attackers by promoting or by saying that I have a lot of many interesting ports that is available and open. So it will be act as a decoy system. So hacker could think about attacking this server first to be able to steal any valuable data. And it helps in detecting attacks, and it can also be implemented in the internal network. But as Honeypot system is costly somehow, we think about implementing it is in most critical or in most areas in network that could be subject to attacks. Intrusion detection system is another kind of control in security that is able to detect attacks or detect application level attacks. So intrusion detection system rely on a signature, and if this signature matched, it will raise an alarm that there is a kind of attack happening to one of the application. For example, intrusion detection system can discover, for example, the DOS attack by saying that I have 100,000 SYN requests received from specific source. So this could indicate a DOS attack based on SYN. This is an example for signature. And then IDS or intrusion detection system can generate an alarm that there is an intrusion is happening. Intrusion detection system can be a signature based or can be neural based. And what we mean by neural based is that it is based on AI. And it can be helpful in detecting zero-day attacks because it would be based on the, let's say, the behavior of the traffic. Zero-day is unknown attack, so no patch available to it, just in case you need to remind what is the zero-day. Intrusion detection system doesn't have preventive capabilities. Either it is unknown attack from the perspective of the signature-based antivirus. Yeah, from the vendor. Yeah, so it is unknown, so we don't have a patch for it from the vendor perspective. And there is another interesting article I read earlier that defines zero-day attack as the patch or the vulnerability that the organization didn't yet patch it. So maybe the patch could be released from the vendor, but the organization didn't apply the appropriate patch. So it is in this case also a zero-day. but it is an unofficial term, by the way. But we are mentioning that 0-day is not only from the perspective of the vendor, but also from the perspective of the environment that could be targeted. Intrusion detection system does not have prevention capability. So intrusion detection system can only detect, but cannot protect against attack, either because the product itself doesn't have this kind of capability, or as per the design of the product. What we mean here is, in some cases, I may have a kind of very critical system, such as core banking, and I don't need to place an IPS that could be able to intercept and deny the traffic. So in this case, I do a kind of port mirroring and send it to IPS system. It is IPS by the control objective, or in other words, has the capability to prevent, but its location in the network does not allow it to intercept the traffic, so it cannot prevent the attack. So that's why we mean, that's what we mean by IDS could not be able to prevent the attack if the design or if the location in the network does not allow him or allow it from doing so. Because you may read in some resources that IDS is an older technology and it is not used anymore, and it can only detect but cannot prevent. But in fact, we can use IPSs nowadays as IDS only, according to the need, or according to how we place or how we design our solution or how we design our network. Intrusion prevention system is an IDS but with prevention capabilities. It does this by monitoring key areas of computer system and looking for bad behavior such as worm, Trojan, spyware, malware, and hackers. It complements a firewall and it provides complete protection from emerging threats. Able to block new 0-day attack because it's not reliant on identifying and distributing a threat signature or batches. So IPS also are based on neural network or artificial intelligence to detect the 0-day attacks. Here I am discussing the implementation difference between IPS and IDS, and as you can see here, IPS is placed to intercept the traffic, but IDS is placed far away from traffic direction. But we do a kind of configuration on this network port to copy the traffic passing this switch to the IDS. So we are using IDS only for traffic monitoring purpose, no more than like this. Okay.